In this video, we're going to talk about the theory of consumer choice. So this chapter is really based upon a model that economists call the model of utility maximization. So we're going to be thinking about utility. And utility is really, the way that economists use the word is really kind of in place of human well-being. Sometimes you hear people talk about utility in terms of happiness, but it's not necessarily happiness. It's just that you consume goods and services that provide you with utility. Certainly some of them can provide you with happiness, but we think of it as well-being. Okay, so basically we're going to think about how to use that model to understand the decisions that a consumer makes. So in this chapter, we're going to be thinking about where demand curves come from. And we're going to be thinking about some of those things that you would have learned about when we first introduced demand and supply to you, things like the income and substitution effect. In this chapter, we're going to actually be able to see those things in action. So what we want to do is we want to think about the decisions that we make in terms of buying goods and services. So we're going to reduce the consumer's problem down to something that's as simple as we can possibly reduce it to. And so if you think about your goal as a person, your goal is going to be to take the income that you've got, the resources that you've got, and use that income to purchase the best combination of goods and services that you possibly can. So we're going to be thinking first about what we're going to call a budget constraint. Budget constraint. So you are constrained by the income that you've got, by whatever your budget is. So the goods and services that you can purchase are the set of goods and services that you can afford. Now, we're going to suppose that you can't borrow money and there's no saving that takes place. We're going to think about this as just a single time. You've got a certain amount of money and you want to spend that amount of money to buy the best combination of the goods that you can, and there's no reason to save any money tomorrow, and you can't spend more money than you've got. So we're going to keep everything really simple. We're going to start by thinking about just two goods. That's as simple as we can get. We're going to think about pizzas and we're going to think about Cokes. We're going to consider a consumer who has to take a certain amount of money. Let's say that the income that they've got, or their budget, let's say, is $500. Okay, so you've got $500. Maybe this is for a month. Okay. And you've got to decide, well, how should I spend that on pizzas and Cokes? Okay, those are the only two goods that there are. Don't worry about anything else, rent or fuel or anything. Your life in this problem consists of deciding how to spend your $500 on pizzas and Cokes. So now let's think about some prices. Let's suppose the price of a pizza, I'm going to call that P with a little P subscript. Price of pizza, let's suppose $10 per pizza, and let's suppose that the price of a Coke is, say, $2. So now we want to think about the combinations that you could purchase. And there's an infinite number of combinations. One possibility would be to take all of your money and spend it all on, say, pizzas. If you took all 500 of your dollars and spent that money completely on pizzas at $10 a piece, you could purchase 50 of them. You could also spend all of that money on just Cokes if you wanted. And if you had $500 and you spent it all on Cokes at $2 each, you could buy 250 Cokes. So what I want to do is create a table. Those are just two possibilities, and probably no reasonable person would want to spend all their money on one good or all their money on another good. Typically, we like to have some of multiple goods. So I want to put together a table here that just includes some possibilities. I'm going to say here pizzas This will be the quantity of pizzas that you could consume, and then the quantity of Cokes that you could consume. Let's say the spending on pizzas, spending on pizzas, spending on Cokes, and then let's put our total over here. That's the total amount of money that we've spent. Now, remember, that total is going to add up to 500 because we can't spend more than the $500 that we've got. So let's start where we spend all of our money on pizzas. If we purchase 50 pizzas and 0 Cokes, then we will have spent $500 on pizzas and $0 on Cokes. That's our $500 total. So that's one possibility, but chances are we're not going to want to spend all of our money on pizzas. Another possibility, and there are an infinite number of possibilities if we assume that Cokes and pizzas are infinitely divisible. Don't worry about that. Let's suppose we decided to spend money on 40 pizzas. Well, at $10 each, that's going to be $400, right? So we've spent $400 on pizzas. That leaves us $100 that we can now spend on Cokes, and at $2 each, we can purchase 50 Cokes. So that's $100 spent on Cokes. That's our $500. So that's another possibility. We could purchase 40 pizzas and 50 Cokes. Or we could purchase 30 pizzas. That would be a total amount of $300 spent on pizzas. That would leave us $200 that we could spend on Cokes, and at $2 each, that means we could buy 100 Cokes. So there's our 200, and those two add up to our 500. And you can see where we're going with this. We're just going to be thinking about spending less, buying fewer pizzas and more Cokes, and these two numbers are always going to add up to 500. So another possibility would be to purchase 20 Cokes. That's $200. That would leave us $300 that we can purchase 20 pizzas. That's $200. That would leave us $300 that we could spend on Cokes at $2 each. That's $150. So there's our 300, and again, those add up to 500. The next one would be 10 pizzas, 200 Cokes. That would be $100 spent on pizzas, $400 spent on Cokes. And then we get to the other end where we're buying no pizzas. We're instead purchasing 250 Cokes, so we've spent nothing on pizza, all $500 on Cokes, and that total that we've spent is 500. So those are some possibilities, right? Now, our question is, well, which one of these is the consumer going to consume? Or there's, remember, a whole bunch that we don't have on this table. You could buy 31 Cokes or 31 pizzas, or 15 pizzas. So there's these are just some representative points. What I'm going to do though is I want to graph these. And let's look at what this looks like visually. What I'm going to do is I'm going to put the quantity of pizzas on the horizontal axis and the quantity of Cokes on the vertical axis. And we're just going to think about graphing the possibilities here. Now, in an economics class, students are used to typically seeing a demand-supply type picture. So you're probably used to seeing pictures where we've got a quantity on the horizontal axis and we've got a price on the vertical axis, or vice versa. You have to be careful because this is not that picture. This is a picture where we've got a quantity on this axis and a quantity on that axis. And we're thinking about the combinations of these two goods, Cokes and pizzas, that we can consume. So one possibility if we're thinking about Cokes, is that we could spend all of our money on Cokes and we could buy 250 of them. So there's that point right there is a point that is going to be on this budget constraint. And then there's a whole bunch of points in between there, and the other end point is where we purchase 0 Cokes, but 50 pizzas. That's another point. And then if we connect those 2 points, we get the budget constraint. Now we could go through and we could graph each one of these points, but each one of those would lie on that budget constraint. Once you know the end points, then you just draw a straight line in between them. So that represents our budget constraint. Sometimes you might hear people talk about it as maybe a budget line. I've even heard it called the consumption possibilities frontier. Occasionally I will use that terminology because it makes sense. These are all of the possible bundles that you can consume. Okay. Let's talk about what the slope of this thing is. So the slope here, if we were to think about the slope of this is going to be this rise over the run. It's going to be 250 divided by 5. The slope of this is going to be 5. I'm just going to write 5 over 1. You go down 5 over 1, down 5 over 1. By the time you've gone down 250, you've gone over 50. Okay? Now, I'm also going to show you how to graph that in general. It's actually very easy. So here's what this budget constraint looks like. It's actually very simple. Income, we're going to spend all of our income. And so our income is going to be equal to the amount that we've spent on, say, Cokes, the price of Coke times the quantity of Cokes we've consumed or purchased. This is the amount that we've spent on Cokes, plus the price of pizzas times the amount of pizzas that we've purchased. So this is the amount spent on Cokes, the amount spent on pizzas. If we add up the amount we've spent on each, it has to add up to our income. Okay, so I'm just going to, a lot of times we might call that just I. Now, here's what I'm going to do. I'm going to solve this. I want to graph this thing. Now, if I want to graph it, I need to solve for the thing that I've got on the vertical axis right up there. I need to solve for the quantity of Cokes. So I'm going to move this thing to the other side. I'm going to have income minus the price of pizzas over multiplied by quantity of pizzas is equal to the price of Cokes multiplied by the quantity of Cokes. All I've done is move that to the other side, and of course I called that I. Now, just for convenience, whatever I'm solving for, I always like to have on the left-hand side. So I'm just going to reverse everything. I'm going to rewrite it this way. Price of Cokes times the quantity of Cokes is equal to income minus the price of pizza times the quantity of pizza. I haven't done anything. I just reversed it. In order to get that quantity of Cokes by itself, I simply need to divide by the price of Cokes. Right? So if I divide by the price of Cokes, it's going to cancel out over here. That's going to leave me just the quantity of Cokes, which is what I want. That's what I'm trying to solve for. So on my left-hand side, I'm going to have the quantity of Cokes. We've got two terms, each of which is divided by the price of Cokes. So I'm going to break those into two terms. I'm going to have income divided by PC minus the price of pizzas divided by the price of Cokes multiplied by the quantity of pizzas. That right there is the functional form for that. If we were to plug in our income, which is equal to 500, and plug in the price of Cokes, 2, and the price of pizzas, 10, then what we would get is our income, 500 divided by the price of Cokes, 500 divided by 2 would be 250. This is your vertical intercept, 250. That's there. This is the slope. the price of pizzas divided by the price of Cokes. 10 divided by 2 is 5. That's where that slope comes from. Okay? So you don't have to write it out like this. You can work through it just by thinking about the endpoints. These endpoints are how many Cokes you could buy if you spent all your money on Cokes. Well, if you had $500 and a Coke costs $2, you can buy 250. This endpoint is how many pizzas you can buy if you spent all of your money on pizzas. Well, if you got $500 and a pizza costs $10, you can buy 50. So you can easily graph this budget constraint with just this information. You don't have to do that, but that may give you a better idea of where it's coming from. Let's talk about what would cause that budget constraint to shift. Well, actually, let's first think about what it shows us. So the budget constraint shows us all of the bundles that we can consume, all the bundles that we can afford. So we can afford this bundle, we can afford that bundle, we can afford any bundle on this budget constraint. We can, of course, afford any bundle in here, right? For example, if we wanted, we could buy one pizza and one Coke. That would cost us $12. That's some point way down in here, right? But we want as much well-being as we can possibly get, and there's no reason to save our money for tomorrow because there's no tomorrow. This picture represents everything. Okay? We can generalize this model to a model that's much more complicated and has multiple time periods. We don't want to do that right now. So we could buy that bundle. We can buy any bundle in here, but we can't buy that bundle. Can't buy that bundle. We can't buy any bundle outside of this budget constraint. Now let's think about what happens if we start to change any of these numbers. If we change our income or if we change what the price of pizzas or the price of Cokes is. Let's suppose that now income is, say, $1,000. Instead of $500, let's suppose we have twice as much income. So let's suppose income is now equal to 1,000. Now, rather than doing this on that picture, I don't think I've got enough space up there to do it. So what I'm going to do is I'm going to draw quickly another version of this, and I'm going to put it right down here. 250. Here's my budget constraint. It goes down here to 50. That's the quantity of pizzas, quantity of Cokes. So there's my budget constraint. Let's think about what happens if now instead of $500, we've got $1,000. Well, that means we're going to be, if we were to spend all of our money on Cokes, instead of just being able to buy 250, we'd be able to buy twice as many because we have twice as much income. So we would be able to buy 500 instead of 250. Or if we were to spend all of our money on pizzas and we've got $1,000, then if a pizza costs $100 or $10, we can buy 100 of them. So this thing, instead of being 50, our end point would be 100, and if we draw that, we get a budget constraint that is parallel to the old budget constraint, and it shows us that now with twice as much income, we can consume a whole lot of bundles that weren't affordable before. With only $500, this is the set of bundles or combinations of pizza and Coke that we could consume. Anything in this set or on this, and we're going to want to be on that budget constraint. But now with $1,000, we can consume any of these bundles, but again, we're going to want to be on that budget constraint. So we're going to be wanting to choose a bundle somewhere on there. Okay? So if we change income, if we increase income, it moves that budget constraint out parallel to itself. If we decrease income, it moves your budget constraint inward parallel to itself. It's important that you recognize that the slope of those two things is exactly the same. Okay? If we calculate the slope of this one, it would be 500 divided by 100, which is 5, just like the slope of that one is. Okay? So changing income shifts that budget constraint out or in parallel to itself. let's talk about a change in one of the prices. Let's think about what happens if we change either the price of pizzas or the price of Cokes. Now clearly, if we increase either of the prices, it makes us worse off. Increasing the price of pizzas decreases the number of bundles that we can consume. Or increasing the price of Cokes makes us worse off. It means that we can afford fewer bundles than before. We'll look at a picture here in a second. Decreasing either price is going to cause us to be able to afford more bundles. So let's think about, let's suppose the price of pizzas falls to $5. So it started out at 10 and it falls to 5. I'm going to do the same thing that I did up here. I'm going to draw this budget constraint again. So we've got the budget constraint, starts out like this, 250, 50. Down here we've got the quantity of pizzas, and up here we've got the quantity of Cokes. So now the price of pizzas is going to fall to 5. It's going to get cut in half. Well, think about what that means. If we've got 5, and I increased our income here to 1,000, let's take our income back to 500. Let's go back to start with these numbers. That's what this budget constraint is based on. Now, if the price of pizzas goes from 10 to 5, that means if we spent all of our money on pizzas and we had $500 and each of them cost $10, we'd be able to buy 100 of them instead of just 50. So if the price of pizzas falls from 10 to 5, we're going to be able to buy 100 pizzas. Now, it's not going to affect the number of Cokes that we can purchase because the price of Cokes hasn't changed. But notice that this budget constraint now is going to pivot out just like that. This thing pivots just like that. And it, again, opens up a whole bunch of bundles that we can consume that we couldn't afford before. But again, we're going to want to be on this budget constraint. So it's going to allow us to produce or to consume any of these bundles that we want. We couldn't have afforded those when the price of pizzas was $10. So if one of the prices changes, notice that the slope of this budget constraint is going to change. The slope of this budget constraint is 250 over 50. The slope of that thing is 5. The slope of this budget constraint is going to be 250 over 100. That gives us 5 over 2. Okay. So the budget constraint is not as steep as before. It's half as steep in this case. Now, what we did there is we decreased the price of pizzas. We could increase the price of pizzas, or we could change the price, or that should be a C up there. We could increase the price of pizzas, or we could change the price of Cokes. We could make the price of Cokes go up or down. Now, so there are 4 possibilities. There are 2 prices, and either of them could go up or down. So there are 4 possibilities. Let me quickly draw those 4 possibilities for you. Let's suppose I'm not going to label everything. I always get on to my students when they don't label stuff. But I'm going to do that for the sake of brevity here. I'm going to draw a budget constraint in each of these, just like the one we're starting out with. What would be on the axis of each of these pictures is the quantity of pizzas and the quantity of Cokes. Okay. Let me label one of them so we can still, there's quantity of pizzas, quantity of Cokes. So now let's think about, in a different color here, I'm going to talk about what happens if each of these prices changes. And so let's do this one first. What we did there is we had a decrease in the price of pizzas. And what we saw was that pivoted this thing out like that. It allowed us to purchase more pizzas than before. So it pivoted out in this direction. In this picture, let's think about what would happen if we increase the price of pizzas. Well, in this case, it's going to pivot our budget constraint in just like that. It's going to cause us to be able to afford fewer bundles than before. I'm using the word bundle here to refer to some combination of pizzas and Cokes, so don't be confused by that. Let's think about what happens now if we change, let's do a decrease in the price of Cokes. Okay, so Cokes is up here on the vertical axis. If the price of Cokes goes down, we can now buy more Cokes than before. It won't change this endpoint because that's how many pizzas we can purchase if we purchase only pizzas. But if we decrease the price of Cokes, it's going to pivot this thing out just like that. If we increased the price of Cokes, it would pivot it in just like this. So you can see all of those combinations would result in a change in the slope of the budget constraint. Okay, so now we understand something about the set of bundles that our consumer can choose from. Any bundle that is on this budget constraint or any bundle in here, but we've already talked about that. We don't want to be inside here. We want to purchase as much as we can. We want to use all of our income. So we're going to want to choose one of these bundles on this budget constraint, but the question is, well, which one? Which one would make our consumer better off? Well, what we need to do in this case is we need to combine this information about what we can afford with some information about what we like, right? We need to represent the preferences of our consumer. And the way that we do that is we represent it with what's referred to as an indifference curve. So I want to think for a second about utility. What I'm going to do is I'm going to draw a little bit bigger picture. I'm going to do the same thing. I'm going to put the quantity of pizzas down here. I'm going to put the quantity of Cokes up here. And we're going to think about the preferences of the consumer. I've said already that utility represents the well-being of the consumer. So the goal of our consumer is to choose whichever bundle gives them the most utility, the most well-being. If you haven't looked into utility before, if this is the first you've heard of it, or if you've heard of it before but nobody's ever really told you much about it, utility is an interesting concept, and it forms the basis really of how economists think about the behavior of consumers. The consumer utility maximization model is really one of the foundational models of how economists model behavior. We don't really believe that you have this utility calculation going on in your head, but turns out that we can model your behavior as if you do. One of the first people that kind of really spent a lot of time thinking about utility was an economist named Jeremy Bentham. If you've never looked into Jeremy Bentham, he's a fascinating person. He really thought in terms of utility about how we can take the things around us and get the most human well-being out of them. He even went so far as to believe that we shouldn't even waste a person's body when they die. Jeremy Bentham believed that the human body, even once a person is dead, could be of some benefit, provide some utility to other people. In fact, what Bentham did was, in his will, he outlined a thing that he wanted built called the auto icon. And the auto icon is basically a big oak cabinet. It's a cabinet inside a cabinet. It's kind of like a display cabinet that's got an outer cabinet that the inner cabinet slides back into. But inside this inner cabinet is Jeremy Bentham's skeleton and his head that has been preserved. He believed that that we shouldn't waste a person's body. When a person dies, we should put that to use and make it available for other people to study, maybe for medical purposes, or maybe so that if you were missing Jeremy, you could, go visit this auto icon, and there he is, right there. So it's not a painting, it's actually Jeremy Bentham. Turns out, though, in the preservation process, the head went bad, and it is pretty grotesque looking. The skeleton has Jeremy's clothes on it. It's fascinating. Just Google auto icon and you will see it. But Jeremy Bentham is kind of one of the founders of the utility model that we use now. We use it differently than he kind of conceptualized it. We've had advancements since then. But look up auto icon. It's pretty fascinating. So here's what we're going to do. We're going to think about how to represent preferences, how to represent utility of the consumer. Let's suppose that we think about a bundle up here. Okay. That bundle would correspond to, I'm just going to put some little dotted lines that would indicate that that bundle corresponds to a whole lot of Cokes and not much pizzas. We're going to start by calling that bundle A. Let's consider bundle A. So the consumer at that point has a whole lot of Cokes, not much pizzas. Maybe like, I don't know. Let's not pay attention to these numbers. Let me give you some different numbers. So ignore those for right now. Let's suppose this is just a bundle for just one day. So that's a bundle that maybe corresponds to 6 Cokes and a half slice of pizza. Okay, so you're sitting there with 6 Cokes and a half slice of pizza. Now here's what I want to do. I want to take some of those Cokes away from you. So I'm going to take some Cokes away, move down that much. And I'm going to give you some pizza in order to compensate you for losing some of those Cokes. So what I would do is I would say, okay, let's suppose I take, say, 2 Cokes away from you. How much pizza would I need to give you to where you're indifferent between the new combination and the old one? Okay? So the old one was where you had 6 Cokes and a half slice of pizza. I'm going to take 2 Cokes away. Now you're only going to have 4 Cokes. How much pizza do I need to give you until you don't care about being at this point and this new point that we're going to call B? So at B, you've got fewer Cokes, but you've got more pizza. And probably if you thought about it a little bit, you'd say, okay, if you take 2 Cokes away from me and give me, I don't know, maybe 1 slice of pizza. So now you've got 4 Cokes and 1.5 slices of pizza. The numbers aren't that important. If you had 4 Cokes and 1.5 slices of pizza, you'd be indifferent. I don't care whether I'm at A or B. Now let's do that again. Let's say, okay, I'm going to take now another 2 Cokes away from you. So I want this distance to be about the same as that, but it looks like I went a little bit too far. So I'm going to take some more Cokes away from you now, and I'm going to give you some more pizza to compensate. So now think about how much pizza you need. If I take the same amount of Cokes away from here as I did there, probably from here you're going to need to be compensated with more pizza. Because as I take more and more Coke away from you, then you've got less and less Coke. When you've got a bunch of Coke and not very much pizza, I could take a lot of Coke away from you and give you a little bit of pizza and you're fine. But now we're getting to a point where you don't have much Coke. And so I'm going to need to compensate you with a larger amount of pizza than I did from A to B. So when we go down here to point C, and I take more Coke away from you, I'm going to need to give you more pizza to compensate you because now you don't have very much Coke. What if I do this again? If I were to take more Coke away, you're going to say, hold it, but wait. I'm going to have hardly any Coke now. And I'm going to say, okay, I realize that, so I'm going to need to give you a lot of pizza to compensate you. So let's suppose I give you this much pizza. So there's point D. Now, exactly where those points would be depend on your preference. It depends on how much you like Coke and pizza. And if through this whole thing you've been saying, oh, I hate Coke, this makes no sense, hang in there. Pretend like you like it. Or for you, pick two goods that you do like, okay? If pizza makes you sick to your stomach, then choose something else, right? So, what we've done here is we've just found 4 points that you're indifferent between. Now, these are just 4 of an infinite number of points that you would be indifferent between. We could change the amount of Coke that we take away and find intermediate points, but if I were to connect all of these, what we would get is what we call an indifference curve, and I'm going to label that with a U and a bar over it because these are points that all provide you with the same amount of utility. You're indifferent between them. You don't care whether you're at point D or point A. Both of those points give you the exact same amount of utility. Okay, so we call that an indifference curve. An indifference curve represents the combinations of pizza and Coke, or whatever 2 goods you're thinking about. It represents the combinations of those 2 goods that leave you with the exact same level of utility. Now, let me draw another picture in here where we don't have all of those points. I'm just going to put an indifference curve in here. We call that U1 with a bar over it. Let's go ahead and put quantity of pizza, quantity of Cokes in there. So there's an indifference curve. I want that thing to look like that. There's an indifference curve. You don't care which of these points you have. They all give you the same amount of utility. And let's think about what would happen if we were to start at a point like that point right there, and then we give you more pizza and more Coke. So we move in that direction to get to a point like that. Well, if you have more of both goods, here we were giving you more of one but taking some of the other away. Here I'm giving you more of both. That means that you would have to prefer that point over that one. So the set of points that would be on the indifference curve, the same indifference curve as that higher point, would be on a different indifference curve. I'm going to call it U2. You get more utility from all of these combinations on this indifference curve than you do on that indifference curve. Okay, so the goal of the consumer in terms of utility is to reach the highest indifference curve because higher indifference curves correspond to higher levels of utility. The way we describe that is that the consumer seeks to maximize utility. They seek to maximize their well-being. So now we can think about actually before we put these 2 things together, let's talk about the kind of the properties of an indifference curve. I've got 2 indifference curves here, but I don't want to go on before we think about, well, okay, so what's important about this picture? We already talked about the fact that higher indifference curves correspond to higher levels of utility. The consumer would rather be on this indifference curve than that one. Or if we had thought about the indifference curve out here, we could call it U3. That would represent high combinations of pizza and Coke that provide higher levels of utility than either of those 2 indifference curves. So the consumer wants to be on the indifference curve that's farthest from the origin. Indifference curves always slope downward. They have to slope downward. We could never have an indifference curve that slopes upward, because if an indifference curve sloped upward, this is getting really cluttered here, but suppose we had an indifference curve that looked like that. Well, that would mean that this bundle A and this bundle B provide the same level of utility, but that wouldn't make any sense because B has strictly more of both goods than A does. So indifference curves never look like that. They're never upward sloping. They're always downward sloping. Okay? Indifference curves can never cross. Same thing. I'm going to sneak that in here. So if we had two indifference curves that look like this, and then another indifference curve that came along like that and crossed, well, that doesn't make sense because if we had a bundle here like A and a bundle like B, and then another bundle like C, here's what this says. Because A and B are on the same indifference curve, the consumer is indifferent between A and B. And because A and C are on the same indifference curve, the consumer would have to be indifferent between A and C. So if they're indifferent between all three of these bundles, we've got a problem right here because C has strictly more of both goods than B. And so the consumer would have to like C more than they like B. So indifference curves never crossed. They nest together just like the isobars on a topographical map. Okay? In fact, that's exactly what this is. If you want a little bit more in-depth view of what's going on in this picture, this is actually a two-dimensional representation of a three-dimensional idea. If you'll go to my intermediate microeconomics videos and go to the one on consumer preferences, you'll find a more in-depth discussion of what's happening here. We don't need to get that in-depth, but they can never cross. And then indifference curves are always curved in this direction. They're never curved in the other direction. They're never curved like this. That would not obey the way that consumers behave. What this says is that when I've got very little of something, you don't need to give me very much to take even more away from me. It disobeys one of the basic laws of how we know people behave. It refers to something called the law of diminishing marginal utility. It's not something we need to get into for this video, but again, if you want to see more on that, go to my intermediate micro videos. Okay, so now what we need to do is we're going to talk a little bit more about kind of what this tells us about your preferences, and then we're going to put these things together, but I clearly need to erase the stuff I've got on the board. Let's think about the shape of these indifference curves. I'm going to give you a couple of unusual, or let's say extreme cases of indifference curves. Let's suppose we had indifference curves, or let's think about what would happen if we had two goods that were perfect substitutes. Like say, let's pretend, for a lot of people, Coke and Pepsi would be pretty close to perfect substitutes. Or we could think about something really unusual, like if you had 2 nickels or 1 dime. 2 nickels and 1 dime, those are perfect substitutes for each other. But let's go with our Coke and Pepsi example. Let's put quantity of Coke down here, quantity of Pepsi up here. And let's put some numbers on here. Let's suppose we had 1, 2, 3, 4. 1, 2, 3, 4. Let's think about having, say, 3 Pepsis and 1 Coke. That bundle right there. You've got 3 Pepsis and 1 Coke. Well, if these things are perfect substitutes, then we could take 1 Pepsi away, give you 1 Coke. That would take us to that bundle, and you'd be indifferent between that point and this point. 3 Pepsis and 1 Coke gives you the same utility as 2 Pepsis and 2 Cokes, or 1 Pepsi and 3 Cokes. That point. So if we connected those, we would get indifference curves that are linear. There's an indifference curve. It's not curved like the other that we saw just a little bit ago. And an indifference curve that would provide you with more utility would also be linear. So those would be what our indifference curves look like. So in the case of perfect substitutes, your indifference curves are going to be linear. They don't have to be linear at a 45-degree angle. It depends on the trade-off between the two. Here I've got 1 can and 1 can, but we could have cans and 2 liters, and then it would be different slope. So that's a special case of perfect substitutes. We could have perfect complements. So if we had perfect complements, let's say that we had, I don't know, say left shoes and right shoes. So let's suppose you had, let's put some numbers up here. 1, 2, 3, 4, 1, 2, 3, 4. Let's suppose you have 2 left shoes and 2 right shoes. So you've got 2 pairs. Well, if you've got 2 left shoes and 2 right shoes, then this bundle right out here, where you've got 2 left shoes and 3 right shoes, that third right shoe doesn't do you any good. You don't have anything to go with it. So you would be indifferent between these 2 bundles. Or if you've got 2 right shoes and 3 left shoes, that bundle, you're indifferent between all 3 of those points. An extra shoe, unless you got another one of the other kind to go with it, doesn't do you any good. Or 2 left shoes and 4 right shoes, that doesn't do you any good. Or 2 right shoes and 4 left shoes. So in this case, our indifference curves look like a L. This is actually what we call lexicographic preferences. You don't have to worry about that term. But if you've got 3 right shoes, you need a third left shoe to go with it. So this combination would be on a higher indifference curve. So it would be on an indifference curve that looks like that. So your indifference curves are right angles in the case of perfect complements. So these are the 2 extremes, linear or right angles, but typically they're going to be curved. They're going to lie in between those 2 extremes. So now let's talk about what the consumer wants to do. The consumer wants to use the income that they've got to get the most utility. So let's put up here, let's go continue with our quantity of pizzas, quantity of Cokes example. We've got a budget constraint that looks like this. And let's just think about a particular bundle. Here's what we're going to do. We're going to say, okay, let's think about bundle A. Bundle A. The consumer can clearly afford that bundle. We need to know something about the preferences of the consumer. So what we're going to do is we're going to put an indifference curve. We're going to draw the indifference curve through point A. We're going to draw the indifference curve that represents all the other bundles besides this one that the consumer is indifferent between. So let's suppose when we draw the consumer's indifference curve, it looks something like this. We'll call it U1. Well, here's what we know. What we know is that there are some bundles out here that are affordable. The consumer can clearly afford any of these bundles. For example, bundle B. The consumer can afford bundle B, and bundle B would be preferred to bundle A because it would be on a higher indifference curve. So if we think about this bundle right down here, the consumer is indifferent between A and that bundle. But the consumer would have to like bundle B more than that one because bundle B has strictly more of both goods. So B is better. B would be on a higher indifference curve. So let's draw the indifference curve through that point. Let's suppose that it were to look like this. We draw the indifference curve through bundle B, and it comes down here and looks something like that. I'm going to call it indifference curve U2. Well, so we've increased utility. The consumer is better off at B than they were at A. And we know that because they're on a higher indifference curve, an indifference curve farther from the origin. But we're not done yet because there are still some bundles right out here that the consumer can afford that would be preferred to either A or B. And so you can probably see where we're going to end. And the end would be that we're going to choose the bundle that would correspond to the indifference curve. Kind of draw my indifference curve coming right down here, and just touching that budget constraint in one place and heading off like that. I'm going to call it U3, right there at bundle C. Once we've gotten to bundle C, we're on the highest possible indifference curve, the indifference curve farthest from the origin. There is no other bundle on that picture that is affordable that would be on a higher indifference curve than U3. So this bundle right there, that amount of pizza and this amount of Coke, that would be the bundle that would maximize well-being for this consumer. So when the consumer is maximizing their utility or well-being, what we end up with is a place where an indifference curve is just tangent to the budget constraint. Let me draw it a simpler picture. Same thing, quantity of pizza, quantity of Cokes, we've got our budget constraint, and now we know that the consumer is going to choose the bundle where an indifference curve is just tangent to the budget constraint. That would be the bundle that maximizes utility. Notice that when this indifference curve and the budget constraint are tangent to each other, that means that at that point of tangency, the slope of each of them has to be equal. Now we call the slope of an indifference curve, the slope, it's equal to what we call the marginal rate of substitution. Marginal rate of substitution. We abbreviate it MRS. We saw the slope of the budget constraint earlier. It's the price of this good divided by the price of that good. It's the price of pizzas divided by the price of Cokes. All right, now that we know that the consumer will end up choosing the bundle where an indifference curve is just tangent to the budget constraint, now we can use that to start to understand how will a consumer respond if that budget constraint changes. In other words, if we change income or if we change prices, that's going to change our budget constraint, and it's therefore going to change our optimal point that the consumer chooses. So let's start by thinking about how a change in income is going to affect the consumer's choice. So let's start with a budget constraint and an indifference curve just tangent to that budget constraint. We'll call it, I'm going to call this, well, let's go with what we're doing. U bar. I think our textbook actually calls it I. It doesn't matter. Some textbooks call it U, some call it I. It's just an indifference curve. I kind of like this notation better because it tells you that utility is not changing along that indifference curve. Let's call our initial point, point A. Let's continue with our quantity of pizzas, quantity of Cokes example. And so we're going to start at A. Let's identify the amount of pizza and Coke that we're consuming. So at point A, the consumer is purchasing this many pizzas. I'm going to call it quantity of pizzas A, and this many Cokes, QCA. Let's suppose income goes up. If income goes up, we know this budget constraint is going to move out parallel to itself. It's going to shift out something like this. So we have an increase in income. Our budget constraint moves out. Now, bundle A is no longer going to be the bundle that they're going to want to consume. And we know that because there are a whole bunch of bundles right in here that are now affordable that would be on higher indifference curves. So let's suppose that we end up, the consumer now has more money to spend. Let's suppose the consumer ends up at a new point of tangency on a higher indifference curve, and we say point B. Okay? So let's look at how much pizza they're going to consume and how much Coke they're going to consume. Quantity of Coke B. Notice that the quantity of pizza went up and the quantity of Coke went up. Let's think about what this means. This is something that you've seen before, at least you've heard about it. What this is telling us is that both pizza and Coke are normal goods. Because we had an increase in income, and that increase in income led to two things. It led to an increase in quantity of pizza and an increase in quantity of Coke. Well, that's the definition of a normal good. If income goes up and you buy more of the good, then it's normal. And that's happening for both pizza and Coke. Think about where we would have needed to put point B to make one of these goods an inferior good. An inferior good is a good for which when your income goes up, you want less of the good. So if let's suppose Coke was an inferior good, we would need the quantity of Coke to go down. So we would have needed our point of tangency to be somewhere down here, where pizza went up, but Coke went down. Let's draw that picture. Let's do a picture for an inferior good. So let's suppose we've got our pizza down here, quantity of Coke here. We've got our initial point of tangency, say right here at point A. And we've got an increase in income, so that budget constraint moves out. I'm just going to draw dotted lines down here to indicate the amount of each good. Let's suppose that Coke is an inferior good. Well, that means we need this to go down and this to go up. This doesn't have to go up for that to be an inferior good, but you can't have both goods be inferior. If you think that you could, try to draw a picture where you increase income, have your new indifference curve tangent to that new budget constraint, and both goods go down. If both goods go down, you have to move down in this direction. So you can only have one inferior good. The other good's got to be normal. So if this one's going to be inferior, that one's got to be normal. That means our point of tangency needs to be somewhere down here. So we would need to have our indifference curve come down here and be tangent, something like that at point B. That would be a situation where income went up, but the consumer bought less Coke. They bought more pizza. So pizza's a normal good, Coke's an inferior good. So now we understand how changes in income affect the amount of Pepsi and pizza and Coke that we're consuming, or that our consumer is consuming. Let's think about how changes in prices are going to affect this. Let's suppose the price of one good falls. Let's start with a picture of equilibrium. So let's suppose we've got our initial equilibrium right here at point A. Call this indifference curve U1. So we've got same thing. Let's do quantity of pizzas, quantity of Coke. Here's the quantity of Coke at point A, quantity of pizzas at point A. We're going to focus on what happens if we change the price of pizza. So let's start at A and let's decrease the price of pizza. If we decrease the price of pizza, that means the endpoint of this budget constraint is going to move out in this direction. Now, when you're drawing pictures of this stuff, I always encourage my students to make your changes in your budget constraint large. How much it shifts depends on how much price changes. But if you're just drawing pictures like this, it's easier to draw everything if things are more spread out. So I'm going to have a large decrease in the change of, or in the price of pizzas, something like that. Shifts out a lot. And so now the consumer would no longer choose bundle A. They're going to choose a bundle on this new budget constraint. Let's suppose they choose a bundle down here on indifference curve U2. That bundle right there, we'll call it bundle B. And so notice that what they're doing is they're buying more pizza than before. That's quantity of pizza at point B. Now what we did is we changed the price of pizza. We lowered the price of pizza. And we saw that they bought more pizza. This would represent the two pizza prices, and these two quantities would represent 2 points on the demand curve for pizza. This is where demand curves come from. Now, we can also see that the quantity of Coke changed when the price of pizza changed. And we know that a change in the price of a related good will shift the demand curve for the other good. So that's what we're seeing there. But I want to focus right now on this. Actually, what I want to do is clear the board off and draw another picture and show you exactly where the demand curve comes from. All right, now let's take a look at where a demand curve comes from. We've got all of the ingredients in what we just did over here, but let's put that picture or a similar picture of what we just did together with another picture, and I think it'll be really easy to see exactly where the demand curve comes from. So we've got the quantity of pizza here, we've got the quantity of Cokes here. Let's put our budget constraint, our initial budget constraint, an initial point of tangency, indifference curve U1, and an initial point, point A. Now down here, I'm going to draw another picture. And I'm going to put the quantity of pizzas on the horizontal axis right there. But on my vertical axis of this picture, I'm going to put the price of pizzas. So what this picture is going to represent is this is going to be a demand picture, right? Because a demand curve has the price on the vertical axis and the quantity on the horizontal axis. Up here, remember, this is not a demand picture. This has got quantity on both axes, two different goods, but this is allowing us to look at the choice between two goods. Down here, we're going to focus just on pizzas. So what I'm going to do in this picture is I'm going to be changing the price of pizzas. I'm going to be decreasing it. Now, this budget constraint is drawn based upon a price of pizzas. And let's pretend that it's right there. Let's say that there is, I'm going to call that PA. That's the initial price of pizza. We don't need to worry about what the number is. In my original picture I started the video out with, or my original example, it was $10. But let's just call it PA, the initial price. Okay, so right here at that initial price, here's the quantity of pizzas the consumer wants to buy. I'm just going to drop this straight down because this quantity and this quantity are the same. So right there, I'm going to call that QA. Okay, so that's where we're starting. We're starting with a price of pizzas and a number of pizzas the consumer wants to buy. Now, here's what we're going to do. We're going to decrease the price of pizzas. Okay? When we decrease the price of pizzas, this budget constraint pivots out. It's going to pivot out something like this. So we've decreased the price of pizzas. Let's suppose here's the new lower price of pizzas that I'm choosing. I'm going to call it PB. Maybe instead of $10, it's now $6. The numbers don't matter. I'm decreasing the price of pizzas. My budget constraint shifts out like this. And now the consumer is going to move to an indifference curve farther from the origin. Let's suppose it's an indifference curve that's tangent right out here. Let's call it U bar 2. And suppose our point of tangency is right there at point B. Now notice what's happened. We decreased the price of pizzas, and the consumer is buying more pizzas, right? There's QB. And so now at this new lower price, there's the new quantity of pizzas the consumer wants to buy. There's QB. We've got 2 points on an indifference curve now. Let's do it again. Let's decrease price again down here to this price, PC. When we decrease price again, this budget constraint is going to pivot out again. It's going to pivot out something like this. And the consumer is no longer going to choose point B. They're going to choose a point out here where the indifference curve would be tangent. Something like point C on indifference curve U3. And now notice what we've got. We've got a lower price of pizzas and a higher quantity demanded. There's QC. We can drop that on down. And so we get another point down here on the budget constraint, or excuse me, on the demand curve. And so if we connect these points, we're tracing out the demand curve for pizza. So this is where demand curves come from. At the beginning of a principles class, we never would go through that. We just say, okay, here's what a demand curve looks like. We would talk about the income and substitution effects, and we're going to see those here in a second. But what we would say is there's an inverse relationship between the price and quantity demanded. As the price goes down, consumers want to buy a higher quantity. Quantity demanded goes up. Well, this is what's behind that. It comes from this model of utility maximization. Let's talk now about the income and substitution effects, because we can actually use this model to identify what the income and substitution effects look like. So when I teach a principles class, principles of micro or principles of macro, and I introduce a demand curve for the first time, usually we go through a demand schedule, a list of prices and the quantity demanded at those prices. And I point out that there's an inverse relationship, and then we draw it. And that inverse relationship shows up as a downward sloping demand curve. And I always tell my students, okay, that happens. Demand curves are downward sloping because of two reasons: the income and substitution effects. But you can never show that at the beginning of a principles class, because you would need to understand this in order to be able to really wrap your head around what they look like. So that's what we're going to do now. Let's think about the income and substitution effects and how to actually see those. Now, before we do this, let me say you can't see these out in the real world. You can only see it when we're working with this model of utility maximization. What we see out in the real world is we see that when price changes, consumers want to buy a different quantity. But we can't separate out that change into the part that's due to income change and the part that's due to the substitution effect. But on a board like this, we can. So let's do this. I'm going to draw a relatively big picture here so we can get a good idea of what's going on. Let's continue with our pizza Coke example. I'm going to put my initial budget constraint right here. Let's have our initial indifference curve tangent. There's indifference curve U1. There's point A. I'm going to focus on pizza right now. I'm going to call this quantity of pizza at point A. So we're going to start right there. I'm not going to worry about quantity of Cokes. We don't need to focus on that. But if we start at A, and let's decrease the price of pizza, just like we did over there. And again, when you draw your picture, you should be drawing these along with me. If you're not, you need to be pausing the video and drawing these. You will only really start to understand it when you start to draw these things as I do it. So when you draw it, I want you to pivot this thing quite a bit. It'll make it easier to do what we need to do here. So we have a decrease in the price of pizza. It allows us to consume a whole lot more bundles than what we could have before price of pizza went down. We know that the consumer is going to move to a higher indifference curve. Let's suppose that they move to an indifference curve that's tangent right there. You may be asking as you draw these, well, where should I put my point of tangency? Should I make it up here, down there, or down here? It doesn't really matter. Try to do it like I do it. Let's call that B. So here's what we've seen. I'm going to call this quantity of pizza at point B. So we're seeing the same thing as what we saw right there. We decreased the price in pizza. Our budget constraint pivoted out. It allowed our consumer to move to an indifference curve farther from the origin, and now they buy more pizza than before. What we want to do, the movement from right there to right there, is what we would call the total effect. That's all we see in the real world. We can observe that when the price changes, we can see how much more or less the consumer buys. What we want to do is we want to break this up into the part that is due to the fact that that decrease in price causes the consumer to substitute away from Coke and towards pizza, and the part, that would be the substitution effect, and the part that is due to the fact that when the price of pizza goes down, it's like the consumer gets a raise in their income. That's the income effect. So here's how we can do it. If we were to take this new budget constraint right here and pull it backwards, parallel to itself, then that would have the effect of reducing income for the consumer. So if we were to take this new budget constraint, I'm going to do this in a different color. If we were to take this new budget constraint and pull it back parallel to itself until we pulled it back enough that it became just tangent to the original budget constraint. And so that would happen somewhere, I'm going to draw this somewhere right in here. Something like that. And what I'm trying to do, and it's kind of challenging, is I want to draw this so that this budget constraint and that one are parallel to each other. So here's what we've done. We have taken income away from the consumer, and we've taken enough of it away that we have found a place right here. I'm going to call it A prime. Now notice, the consumer would be indifferent between where they started, A, and this point A prime. They would be indifferent. They're no better off at A than they are at A prime. So when we pull this budget constraint back, it's like we're reversing the income effect. And we're reducing them back to their original level of well-being, their original level of utility. And that's what allows us to see visually the part of this change that's due to the substitution effect, and then the part of the change that's due to the income effect. So this point right here, when we hypothetically take income away, what we're doing is we're finding 2 points on our original indifference curve that are due to simply a change in the prices. The consumer's well-being hasn't changed. And notice, it's the income effect that makes you better off. The substitution effect simply causes you to substitute away from the good whose price hasn't changed towards the good whose price went down. So this chunk, that part right there is what we call the substitution effect. we're moving around the indifference curve because the prices have changed. This part, from there out to there, that is your income effect. It's the part that is due to the fact that this decrease in price has given you more purchasing power. You can buy more bundles than before. Now, I can remember the first time I saw this thinking, wow, it's going to take me a few times to go through that and wrap my head around it. And back then, there wasn't any YouTube. There weren't any videos that you went to watch this. You just went to a textbook and you read through it. Or you went and visited a professor and said, hey, can you kind of run through this again? But what I would do is I would go back and watch me go through this again. If it's not clear the first time, it may take a time or two. So that allows you to see the income and substitution effect. And again, we can't do this in the real world. This is something that is only possible right here on the board. But that's what the income and substitution effects look like. Let's talk about something that economists know as the Giffen good, or a Giffen good. So if you were to take one of my economics classes, or if you've been watching my videos, you know that there are many, many times that I talk about the steepness of the demand curve. And so if you've made it to this part in the Principles of Micro class, you've probably already talked about elasticity. You know that elasticity is a measure of the steepness of the demand curve. And so we can have demand curves that are perfectly inelastic, straight up and down, or we can have demand curves that are inelastic or perfectly elastic, but typically they're going to be downward sloping. We don't have demand curves that are upward sloping. In fact, my opinion is it doesn't exist. Now, there are other economists that believe that maybe there's some place out there where it has existed in the past. I don't believe so. I have never heard any evidence for a Giffen good that I've found persuasive, but who knows? It could be out there. But let me show you theoretically why it can exist. There's no reason theoretically that a demand curve can't be upward sloping. So here's what I'm going to do. An upward sloping demand curve would be referred to, or the name we've chosen to give it would be a Giffen good. So let's look at what this Giffen good would have to look like. So I'm going to put, I'm just going to call this quantity X and quantity Y. I don't want to go with my pizza and Coke example because neither of these goods are Giffen goods. So I don't want anybody watching this video and somehow thinking that I'm trying to demonstrate that pizza is a Giffen good, because it's not. So we're not going to call these anything. It's just X and Y. So I'm going to put my budget constraint, my initial budget constraint right here. I'm going to have an initial point of tangency, say right here at point A. Here's my indifference curve, U1. And now I'm going to decrease the price of good X. So let's start out here. Here's the initial price of good X, or quantity of good X. I'm going to call it QXA. And I'm going to decrease the price of good X, something like this. There's my new budget constraint. It pivoted out as I decreased the price of this good. Now here's what I need. When that price falls, for just a regular downward sloping demand curve, what you need when the price falls is you need the consumer to buy more of it. But notice on this picture, when this price falls, if I were to put my point of tangency right up here, so for example, I'm going to put remember indifference curves can't cross, but I don't need them to cross. I can make them very close to each other right here, and then cause this one to be tangent right there, and then head on down just like that. I have not violated any property of indifference curves by drawing it like that. My new point of tangency is right here at point B. Now, notice here. Notice this. Here's the quantity of good x at point B. We had a decrease in the price of good x, and in my picture that led to a decrease in the quantity demanded of good x. That's an upward sloping demand curve. So notice A and B, B is to the right of A in this picture. This is how things work out there in the real world. But there's no reason I can't draw a picture with B right up there to the left of point A and still not violate anything about this utility maximization model that I'm using. But I've got a Giffen good. I've got an upward sloping demand curve. Now again, I'm just going to say that I do not believe these exist out there in the real world, but I am always prepared to be wrong. So let's go ahead and look at what if we were to separate this out into the income and substitution effects. If we took this second budget constraint and pulled it back, it's going to be tangent somewhere right in here. So if I were to take that thing, let me do this in a different, let's do it in this color. If I were to take this and pull it back, it's going to end up being tangent. So I want that and that to be parallel. It's going to end up being tangent somewhere right there. There's A prime. So notice that my substitution effect, here is quantity x A prime. I didn't label it over here, but there's quantity x A prime in that picture. This movement is my substitution effect. I'm just going to call it S. And then this movement from right here to right there, that's my income effect. This is a very inferior good. There's my income effect. So notice that if a Giffen good were to exist, it would have to be an inferior good, and it would have to be a good that is so inferior that the income effect outweighs the substitution effect. There are plenty of inferior goods out there, but the income effect is always small relative to the size of the substitution effect. That's just how it works in the real world. But again, there is an example of a picture where the income effect is bigger than the substitution effect, and so you get an upward sloping demand curve. Let's do a quick application of this. Let's talk about labor supply. I'm gonna try to finish up right down here. If we talk about labor supply, let's put a picture right down here. Get a little bit. Okay, so now let's talk about a person's decision of how much to work. So let's keep this nice and simple. Let's suppose that a person has maybe 100 waking hours during a week. I don't know how many hours there are during a week. There would be 24 times 7, 160 something. Let's suppose you spend 100 hours awake. Now, of those hours that you spend awake, you have to decide how many of them to work and how many of them not to work. Let's say your choice is between work and leisure. Okay, so on my horizontal axis, I'm going to put leisure. How many hours do you engage in leisure? And let's suppose right out here is 100 hours. That's the most hours that you could engage in leisure. Let's suppose on the vertical axis we put income. This is money that you can spend on consumption. So you have to decide how much time should I spend engaged in leisure and how much consumption do I want? How much income do I want to have to buy the goods and services that I like to have? Let's suppose that the wage starts out at $10. Wage is equal to $10. Well, if you spend all 100 hours of leisure, or all 100 of your waking hours engaged in leisure, you have no income. You're not working. The other option would be to spend all 100 hours working at $10 an hour, and then you would have, let's say, $1,000 of income. Those are 2 points on what we're going to connect as your budget constraint. Right there would be your budget constraint in this situation. And so let's suppose that you have an indifference curve that's just tangent, say right there. Call it point A. So you choose this amount of leisure, you work this amount, and by working that amount, it gives you some income that you can spend on stuff. Not $1,000, because you're still engaged in some leisure, but you're earning some income. Now, let's think about what would happen if your wage goes up. Let's suppose your wage goes to, now wage is equal to $20. If your wage is equal to $20, then instead of being able to earn $1,000, you can now earn $2,000. And your budget constraint would pivot up. It would pivot something like that. And so let's suppose now, when your budget constraint pivots up, let's suppose your point of tangency is something like this. Right up here at point B. So notice what happens now. When the wage was $10, you chose this much leisure. But now that the wage is $20, you choose only this much leisure. In other words, when the wage goes up, you work more. Not surprisingly, right? So a higher wage, you sell more of your hours for labor. But here's the interesting thing. Here's why we're talking about this. Let's suppose that we consider a large increase in your wage. Let's suppose the wage equals $40. Then this budget constraint is going to pivot up quite a bit. Actually, I don't have enough space. 4,000 would be somewhere up here. And so your budget constraint would be something like this. Now, let's suppose, when that happens, let's suppose you're going to move to a higher indifference curve. This is going to make you better off, but let's suppose that your new indifference curve is tangent right out here, say at point C. We haven't violated any of the properties of indifference curves or anything there, but notice what happens. When that wage goes up to 40, notice now, compared to B, you work less. So from A to B, you're working more. You're engaged in less leisure. But then when the wage goes up to 40, you now choose to work less and engage in more leisure. If we were to draw your labor supply curve at a wage of 10, a wage of 20, and a wage of 40, so here's our wage, here's labor supply, this is the amount of work that we do. What we see is that when the wage went from 10 to 20, you engaged in less leisure, you worked more. So your labor supply curve would look something like that. But then when the wage went up to 40, all of a sudden you worked less. And so what would happen is this labor supply curve would start to bend back on itself. And actually there's a lot of evidence out there in the real world for labor supply curves looking like this. We call it a backwards bending labor supply curve. What's happening here is that When the wage gets high enough, because leisure is a normal good, that income effect causes you want to have more leisure. You don't have to work as hard to make the same amount of income. And so out in the real world, what happens is, when the wage is relatively low, as it increases, you sell more labor. But at some point, you start to sell less labor. And so there's evidence for that out there. It's a nice application of this model to the decision of how much to work, right? And we can apply it to other things. I think the textbook has an example of how a change in the interest rate affects the amount you save. It can be applied to all kinds of things. Hopefully this gives you an idea of kind of the way people make decisions. It helps you understand a demand curve in a way that you wouldn't have understood it when you just look at a demand curve like that. So I'll see you in another video.